About 71% of our world is covered in water, and the ocean accounts for 96.5% of the world's water. This means that much of our daily lives are formulated around knowing what the oceans can offer us, so we have studied the oceans for years. This has involved us traveling great distances with the oceans and going on diving expeditions to explore what may linger within the vast oceans. With these many expeditions we have taken throughout the years of exploring the oceans, there is a part of the oceans which we still know very little about: the deep sea. The deep sea has been a scientific mystery for years, with scientists knowing very little to nothing about the deep sea and what it holds, only finding bits and pieces of information about it whenever the information presents itself. With this very little information we have received from the deep sea, scientists have been able to speculate and discover their own information about the deep sea. The deep sea is home to an array of unique deep sea creatures, a massive amount of useful materials, and a plethora of technological problems. One of the most interesting information the deep sea has to offer is an array of deep sea creatures. When it comes to the deep sea, it is very difficult for living creatures to subside down there, as the immense pressure, freezing temperatures, and the lack of food makes living in the deep sea near impossible. With the deep sea creatures, however, they are capable of creating their own bioluminescence to see and communicate, adapted to the frigid temperatures and the pressure, and are small enough to not need food for extended periods of time. One of these deep sea creatures that have adapted to living in the deep sea is the deep sea anglerfish. This fish has adapted to the deep sea lifestyle, as its skin is a dark brown to hide itself in the dark, and its spine comes out of its back with a bioluminescent light on the tip that it shakes in order to attract prey. The females also emit a pheromone in which attracts male anglerfish, helping the anglerfish mate in order to avoid extinction. Another one of these deep sea creatures that have adapted to survive within the deep sea is the jumbo squid. The jumbo squid resides within the deep sea, where it rests after hunting by shutting down their metabolism and body in order to reserve their oxygen in the food consumption. When the jumbo squid does need to hunt, however, they turn on their metabolism and proceed to let their jet propulsion movement in order to reach the surface. The last deep sea creature to be discussed is the frilled shark. The frilled shark has an enormous liver with low-density lipids, which allow it to maintain its position in the water with little effort. This mixed with their mechanoreceptive hair cells allowed them to sense the movement of their prey, making hunting in the deep sea doable. These deep sea creatures give scientists the means towards understanding how living in the deep sea may be possible. Not only is the deep sea home to fascinating deep sea creatures, but it is the richest area to find the most important minerals used in everyday life. These minerals include copper, zinc, nickel, gold, silver, and phosphorus. These minerals are usually found near volcanic and other rock formations of nodules, usually discovered on pretty small abyssal plain sediments. Many of these small nodules that are rich in material are typically common in the deep basins of the Pacific and Indian Oceans. The most significant materials can be found in mud within the deep seas, which are used in consumer electronics and many electric cars. These crusts have been recently found, however, due to difficult deep sea excavation, and can be in the issues that come with it. One of the biggest issues that come with deep sea mining are the environmental issues it can cause to the seafloor. This includes how digging into the seafloor with whatever tools needed could leave long-lasting imprints on the seafloor. One experiment done by scientists involved cutting tracks onto the sea floor to see the lasting effects it would have. And due to the weak currents and lack of sediment dropping to the seafloor, the tracks would last on the seafloor for decades. Not only that, but the amount of creatures that used to be natural in that area become less abundant, migrating to separate parts of the deep sea away from their natural habitat. This would mean that if miners chose to use the deep sea for their minerals, they would completely scar the seafloor for decades and push the creatures there away, making it a deep sea dead zone. This has pushed many scientists and U.S. officials to discuss whether or not mining in the deep sea is worth the rich materials at the cost of the environment. With the issues the mineral deposits in the deep sea leave, it only makes sense that the deep sea exploration provides its own issues. One of the biggest issues with being able to create the technology to explore the deep sea is funding. When comparing the funding for the National Oceanic and Atmospheric Administration, or the NOAA, to an organization like NASA, it can be seen that the funding for NASA is roughly 3.5 times more than the NOAA. Without the proper funding, the NOAA cannot have the money to produce the required technology needed to explore and venture into the deep sea. Another major issue that comes with trying to explore the deep sea is the massive amount of pressure while in the deep sea. With every meter that is traveled deeper within the ocean, there is an additional 14.27 pounds of pressure added on every square inch of a given surface. This pressure makes it hard to develop the technology able to sustain this pressure. Some of the most recently developed remote control vehicles, or remote operated vehicles, are ROVs, being produced to sustain almost 3,000 pounds of force per square inch on its surface. Not only does this make producing that technology harder, but it also makes performing maintenance on the technology even harder. The ROVs need to be able to continue serving the deep seas without maintenance, as if it is broken or damaged, it can be near impossible to retrieve it as well as fix it while it is down in the deep with all that surrounding pressure. One of the final issues with deep sea explorations is the lack of oxygen and sunlight. Without the sun, it is impossible to see in the deep without lights developed bright and strong enough to survive that deep. As for the lack of oxygen, this makes it extremely difficult to send explorers down, as if they run low on oxygen, it is very difficult to navigate back to the surface in order to receive more oxygen. All of these factors lead to a biome on Earth incapable of being explored without the time and resources dedicated towards the cause. The ocean covers about 71% of the world, yet we don't know much about it. We have, over time, only uncovered very little information from this biome that encapsulates most of the world we inhabit. We have encountered some of the many deep sea creatures that can be found within the depths of the sea. We have found and uncovered the many materials that can improve our quality of life, all while we have discovered many things from the deep sea. It has posed its own issues that prevent us from completely exploring the deep sea. The only question left when it comes to the deep sea is, where do we start exploring now?